Hi everybody, welcome back. This is going to be what I hope is a short video on monopolistic competition. I haven't proven myself able to do short videos yet, but I'm going to really try for this one. Ignore all of the little codes along the bottom. Sorry, I didn't edit my slides quite well enough before I started the video. Mostly what I want to do with this is I want to just quickly show you how to draw the graphs for monopolistic competition. I really like this topic because I feel like most of the businesses that you and I interact with in the area around Berkeley are monopolistically competitive businesses. If your family owns a restaurant, definitely a monopolistically competitive business. So that's why I like to take time to do this one. So monopolistic competition, excuse me, just to hopefully review, is an industry in which there are lots of firms. There are no barriers to entry and exit. And so far, with those two characteristics, it's very much similar to perfect competition, but it's an industry in which they are producing a heterogeneous product. So it's not the case that everybody is producing zucchini where you can't tell once you get home who the heck grew this zucchini. It's Starbucks versus Peet's versus Phil's versus whatever else types of coffee where you definitely can tell the difference as you're consuming it, because it tastes better at Peet's. And when you get it home, your roommate can look and say, oh, you went to Starbucks or you went to Peet's, based on other information. So there's a heterogeneous product, and that's what makes it different. It's different also because there are people like me who will drink Peet's coffee who will not drink Starbucks coffee. So maybe if there was a huge price difference, I might be persuaded to go to Starbucks, but probably not, because I'm afraid some of you would see me there and take a picture and put it on Twitter and my reputation would be ruined or something like that. In any case, the idea is that there are people who are loyal to one product over another because there are differences between the products. Okay, so that's the essence of monopolistic competition. A monopolistically competitive firm is doing the same thing that any other firm is doing. It's trying to maximize profit. So it's choosing to produce the quantity where marginal revenue equals marginal cost. And the difference with monopolistic competition is that in this case, because the firms are producing a heterogeneous product and they have loyal customers who are willing to stick with the product even if its price is different than the price of a similar but slightly different product at a different firm, each firm faces a downward sloping demand curve. So when we draw it, it looks like this. Let me see here. Let me start with black. I'm going to put the price of the product on the vertical axis and the quantity of the product on the horizontal axis. And this is for the firm. So we've got an individual firm here. There's no market picture for monopolistic competition because remember, when we define a market, we have to define the particular product. Well, Starbucks doesn't sell Peet's coffee. So that means I can't draw a picture that brings together the demand for Starbucks coffee and the demand for Peet's coffee, because there are people like me where ne'er the twain shall meet. And they're not selling the same product. Trust me on this one. It's not the same product. And so this is a firm selling whatever the product. So it's a firm level picture. And then we're looking at the demand and supply by this firm of a particular product. So let's say a small decaf in a medium cup coffee from Peet's. That's what I always get. Small decaf in a medium cup. Okay. And again, we have to have a time frame. Coffee from Peet's, let's say per week. So how many small decafs in a medium cup do you want to buy per week at each of various prices? So for the individual Peet's store, they face a downward sloping demand curve because when the price drops a little bit, not all of their customers are going to go away. The reason that in a perfectly competitive market, the firm faces a horizontal demand is because if they raise their price a little bit, all their customers are going to go away. And that's not true with monopolistically competitive firms. So they face a downward sloping demand curve. That means that their marginal revenue curve is also downward sloping. And remember, the marginal revenue curve splits the distance between the horizontal axis and the demand curve. So it has an angle that's twice as steep, or it splits the difference. I would like it if you just trusted me on why. You're going to have to prove why when you take 100A. If you go to office hours, we can show you it drops out of calculus, and there is no calculus prerequisite for this course, and that's why I'm not going to put it in the video. So for now, I just want you to trust me that the marginal revenue curve is going to split the distance between the vertical axis and the demand curve. The individual firm is going to have the same marginal cost curve that we would have with any other firm, so it has an upward sloping marginal cost curve. And the firm is going to produce the quantity where marginal revenue equals marginal cost. So the profit maximizing quantity is going to be that quantity where marginal revenue equals marginal cost. So find the MR equals MC point, dash that down, and that's the profit maximizing quantity. Now this firm would be foolish. They would be losing profit if they charged the price where if you just dashed over to the left, if they charge that price, that would be silly. They want to earn as much profit as they can, and so they're going to charge the highest price they can charge in order to sell that quantity of Q1. And so we're going to dash that over, and that's price P1. So you find the point where MR equals MC, dash it down, that's Q1, go back up until you hit the demand curve, find that dot, dash it over, and that's the price P1. And so they're going to profit maximize at the price of P1 and a quantity of Q1. Right now, we don't know how much profit they're making. We don't know if their profit is positive or negative. In order to know whether their profit is positive or negative, we need an average total cost curve, because it's the total costs relative to the total revenue that tell us whether they're making profit or not. So let me start this way. Let's suppose that the average total cost curve falls below the demand curve. Remember that your average total cost curve hits its minimum when it crosses the marginal cost curve. So you want to draw it something like that. And so what do we got? From Q1, go up until you hit the average total cost curve, and then dash that over. That's the average total costs of producing quantity Q1. So the average total costs at Q1 go from Q1 up to the ATC, and that tells you the average total cost of producing that quantity Q1. And then profit, remember, is total revenue minus total costs. Well, that's the same as I could call it the average revenue times the quantity minus the average total cost times the quantity, because our total revenue was price times quantity. Oh, price, that's just price. I'll be back to that. Total cost was, or average total cost was total cost divided by Q, so it works out. And so let me factor out the Q. I've got average revenue minus average total costs times quantity. But average revenue, that's just, as I said, sort of muttered a second ago, that's just the price. And so the profit is the price. Well, I can do this. Okay, let me change my colors. I love changing colors. I'll go to orange this time. So at Q1, here's my price, P1. Okay, got that. That's the price P1. My average total costs, Q1, go up. There's my blue dot. Got it. There's my average total costs at quantity Q1. And so the price minus the average total costs at Q1, that's just that vertical distance between P1 and the average total costs associated with selling the quantity Q1. And now I'm going to multiply it by the quantity Q. Geometry has returned, because here's the quantity Q. So I'm starting from 0 and going over to Q1. So there's my quantity Q. Hey, if I take this vertical distance, some might call it the height, and multiply it by this horizontal distance, some might call it the base, I'd have base times height. Base times height, what is base times height? It's the area of this rectangle. And so that tells me that the area of the rectangle is equal to the profit. Cool. Very cool. So here we have a profit maximizing, monopolistically competitive firm that's earning a positive profit because its price is above its average total cost. Let me draw another picture And so now what if instead the what if instead the cost curve lies above the demand curve? So again, here, price on the vertical, quantity on the horizontal, a downward sloping demand curve, that's the demand faced by the firm, a downward sloping marginal revenue curve, standard marginal cost curve. Find the point where marginal cost equals marginal revenue, label it Q1. Let me erase that, oops, eraser. Label it Q1, much better. That's the profit maximizing quantity. They're going to sell it at a price of P1, so let me label this P1. And now, suppose that the cost curve lies entirely above the demand curve. Or it's going to come down, it's going to hit its minimum where it crosses the marginal cost curve. So from Q1 now I go up until I hit my average total cost curve. I dash that over. That's my average total costs at Q1. It's just coincidental that it's hitting the vertical axis at that point where the demand curve started. That's just a fluke. That has nothing to do with anything. It's a fluke. Okay, but the profit, remember, profit is the average revenue minus the average total costs times the quantity, which is the price minus the average total cost times the quantity. So the profit at quantity Q1, and now it's important to note that the average total costs are greater than, the average total costs are greater than the price. And because the average total costs are greater than the price, what that means is we have losses. Ooh, bad. The profit is going to be less than 0. But once again, the profit is going to be found by taking the area of this rectangle, the height of which is the distance between price and average total cost, the base of which is the quantity, the profit maximizing quantity Q1. And so the area of this rectangle is going to be equal to, in this case, the loss. So the area of the rectangle, base times height, equals the loss. Okay, that's cool. That's the short run. What happens in the long run? Well, in the long run, what happens in a monopolistically competitive industry is in the long run, where's my arrow? In the long run, other firms can enter this industry because there are no barriers to entry or exit. Hi everybody, it's Professor Olney. I'm sorry about the change of clothes. I started to record this video in June and I ran out of time and then I was gone for the summer and so now it's August. So I'm going to pick it back up pretty much where I left off. But if you're jarred by the change of clothes, there you go. That's why. So here we go. All right, so what we did before, just to get myself back in gear, was we were talking about monopolistic competition. I showed you the profit maximizing point for a monopolistically competitive firm. I showed you how to calculate the profit or the loss for a monopolistically competitive firm. And now I want to talk about what happens when there's a firm in a monopolistically competitive industry and that firm is earning abnormal profit. So let me draw the picture. I'm not going to use the slides this time because frankly the guy who shows me how to use the slides isn't here and I can't figure it out. So I'm going to just draw from scratch. All right, so in a monopolistically competitive industry, so we're going to have our regular picture. Let me change colors because I can and it's fun to do. Up on the vertical axis, I'm going to have things like marginal revenue and marginal cost and demand and so on and so forth. Down here on the horizontal axis, I'm going to have the quantity. And so we've got some monopolistically competitive firm. It has a downward sloping demand curve, which I'm labeling D for demand. It has a marginal revenue curve that is twice as steep. That, I don't know if I mentioned this before, it's been 2 months. The reason the marginal revenue curve is twice as steep as the demand curve drops out of the calculus. Calculus is not something we expect you to know in Econ 1, so you can just accept that that's what happens. If you're interested in seeing the calculus, ask me or one of your GSIs during office hours, and we can pretty quickly show you the calculus that gives you twice the slope but the same intercept for the marginal revenue curve as you have for the downward sloping demand curve. And then let me add to this a marginal cost curve. So here's my marginal cost curve. And then the profit maximizing point is going to be where the marginal revenue equals marginal cost. That's always profit maximization for any firm. Again, that's something that drops out of the calculus. We don't expect you to prove that. You'll have to prove it in 100A or 101A. And again, if you're interested in it, because calculus is not a requirement for the course, we're not going to go through it in class, but we're always happy to do things like that for you during office hours. Back to the picture. So the profit maximizing quantity Q star, and then of course this firm is going to charge an amount of price for this product that it reads off of its demand curve. Let me call that P star. Let me put some subscripts 1 on each of these things because I'm going to shift things around. And then suppose that this is a firm that has an average total cost curve that looks pretty much like this. So it's going to come down, hits its minimum there, and then goes back up. So there's the average total costs. And again, this will be a firm that, in this case, I have drawn a firm that has a profit. The average total cost of producing quantity Q1 star, we read off the ATC curve. So there's the average total costs at Q1 star. And since the price is above the average total cost, this is a firm that's earning positive economic profit. What happens? Well, in the case where the firm is earning positive economic profits, what's going to happen is other firms are going to enter the industry. So there's going to be entry by other firms. So let me actually put this above here. Profit greater than 0 is going to lead to other firms to enter that industry. Remember, in a monopolistically competitive industry, that's an industry in which there are no barriers to entry. So this is like restaurants on Telegraph Avenue, or coffee shops, or any other sort of boba tea shops on Telegraph Avenue, and so on. Any other sort of small business where there's a slight differentiation of the product, but there's no barriers to other firms entering the industry. So entrepreneur looks around, sees people are making a whole lot of profit selling boba tea on Telegraph Avenue in Berkeley, decides, hey, I could do that too. They decide to enter the industry. What that does for the original firm, which is what's pictured here on the graph, what that does for the original firm is it takes away some of their customers. And so the original firm is going to lose customers. That means their demand curve is going to shift to the left. And when their demand curve shifts to the left, their marginal revenue curve shifts to the left as well. So let me show you an example of that. I just love having all these colors. It's fun. So now the demand curve, let me shift my demand curve to the left. I'm going to do this in a really accentuated way just to make the point. So there's the new demand curve. I'll call it D2. Because there's a new demand curve, there's a new marginal revenue curve. So I have a new marginal revenue curve, MR2. And now you'll see that there is now a new, different profit maximizing quantity for this firm. Not surprisingly, they're selling a lower quantity. That's because other firms have entered the industry and competed away some of their customers. They are selling that lower quantity Q2 at a lower price. Not surprisingly, the price that they're able to charge has fallen because they're losing customers, and so they can't charge as high a price anymore. And now the way that I've drawn this, now we've got a firm that is definitely incurring a loss. Now this firm has the average total costs at quantity Q2 are in excess of its price at quantity Q2. Now it's possible I could have drawn this drop in demand being a little bit smaller, have a smaller size drop in demand, and then you would have seen still a profit but a smaller profit at the new quantity and the new price. It's pretty hard, the way that I had drawn this originally, given how small of a profit box I had originally. It was going to be hard for me to draw a little shift of demand to show a little shift in demand and a little shift in marginal revenue and a little shift in quantity, resulting in a decrease in profit but still positive profit. That's what would happen in the real world. Just hard to show on the graph because all the lines were going to be so much on top of each other, you never would have been able to see what I was really doing. So this is the effect of having abnormal profit. A firm in a monopolistically competitive industry that has abnormal profit will see others enter the industry, and that will compete away some of their profit. They're going to lose some of their customers, just as we saw here. So profit greater than 0 leads to entry by other firms, which leads to a decrease in profit enjoyed by the original firm. So decrease in profit for the original firm. So is there a long-run equilibrium? Absolutely. There's a long-run equilibrium because this process of other firms entering the industry when there is an abnormal profit, and then the reverse of that would be firms leaving the industry when there are losses. The result of that is going to be firms are entering and exiting the industry until you reach the point where the typical firm is earning zero economic profit. That is, they're doing just as well as this in this industry as they could do in any other industry. Let me show you the picture for what it looks like when we're in the long-run equilibrium in monopolistic competition. So let me get me a new sheet of paper, and let me start with a new set of axes. So I'm going to have a new graph over here. Once again, we're going to put marginal revenue and marginal cost and other things that are all measured in dollars here on the vertical axis and quantity on the horizontal axis. Let me draw a downward sloping demand curve, demand D. I'll just call it D, that's fine. That's going to give us a downward sloping marginal revenue curve, MR. And here for this firm, we're going to have the standard upward sloping marginal cost curve, MC. The firm is going to maximize profit by producing the quantity where marginal revenue equals marginal cost. Dash that down, Q star. So Q star is the profit max quantity. The price they're going to charge go up until you hit the demand curve. They're profit maximizing, so they're going to charge the maximum price they can to sell the quantity that gives them the maximum profit. So they'll charge a price, P star. And now, what's the long run equilibrium? In the long run, the firms are earning zero economic profit. So if they're earning zero economic profit, that means that their average total cost, so in the long run, there's going to be zero economic profit. And that means that the price is going to be exactly equal to the average total cost at that quantity Q star. Remember that the average total cost hits its minimum when it crosses the marginal cost curve. So what happens? Here it comes. The average TC comes down, is tangent to the demand curve at the profit maximizing quantity, continues down until it reaches marginal cost, and then goes back up. So there's my average total cost curve, and then draw a nice big dot so it looks like you did it right. And there is the point where the price is exactly equal to the average total cost, and we call this the long run. Where do I want to write that down? Let me write it in a new color as long as I can. That is our long run equilibrium in monopolistic competition. The reason that the average, a lot of people ask me, why is the ATC tangent to the demand curve? Why doesn't it cross the demand curve at that point where the marginal revenue equals the marginal cost? I could prove it to you, but this again is not something I'm going to do in class because again it involves the calculus. Let me give you just a little hint. So the hint comes from trying to remember that the marginal revenue curve is telling you about the slope of total revenue, and the marginal cost curve is trying to tell you about the slope of the total cost curve. And since the marginal revenue and the marginal cost curves are equal at that quantity Q star, that means the slopes of the total cost curve and the total revenue curve have to be equal at that same quantity Q star. And since the average cost is the total cost divided by the quantity, and the demand is the total revenue divided by the quantity, it's the average revenue, that means that those two curves, your demand curve and your average total cost curves, those have to have the same slope if their marginal revenue and marginal cost is equal. So once you find the quantity, let me do this as one sentence, once you find the quantity at which MR equals MC, at that quantity, it also has to be the case, because of the definition of MR and MC, it also has to be the case that at that quantity Q star, the slopes of the the slopes of the average total cost curve and the average revenue curve, which we call the demand curve, have to also be equal. So that's why the ATC is tangent to the demand curve at that point. That's why it can't cross at that point. The slopes have to be equal, and if the slopes are equal, they can't cross. They have to be just tangent. All right, that gives us the long run equilibrium. That wraps up the monopolistic competition. What we can do with it is we can then show the effects of, for instance, a change in variable costs, which would shift the marginal cost curve, a change in fixed costs, which would shift the average total cost but not the marginal cost curve, a change in demand if there are more customers that come into the industry as a whole. We could show that as well. But we're not going to do that on this video because it's already gotten pretty long. All right, y'all have a great day. Go Bears!